today's lesson is on solving an absolute value inequality. Let's look at the steps first. Step 1, let's rewrite the inequality as a conjunction or a disjunction. All that means is let's rewrite the inequality as an and statement or an or statement. So if we have a less than or equal to, we have an and statement. If we have a greater than or equal to, we have an or. Greater for is an or, less than is an and. And that's step 1. Step 2. In the second equation, we must negate the right-hand side and reverse the direction of the inequality sign. All that means when we negate is we multiply a negative 1. And remember, when we multiply by a negative number, we have to flip the sign. Step 3, we solve the compound inequality. Okay, let's look at a problem. What does absolute value of x greater than 4 really mean? Remember, we got that greater. So step 1 said what? Rewrite this as a and or an or. Greater, so we're going to rewrite as an or statement. We got x less than negative 4, or, got that or, x greater than 4. Okay. So, x, remember we take the first one, just rewrite it. Or, drop the bars for the second one, and multiply by negative 1, so we flip this on. And now all I've done down here in the bottom is to switch them around. Look at the graph. We have an open circle on 4 and negative 4. Negative 4 is pointing to the left, so we point left. Positive 4 is pointing to the right with an open circle. Notice that you need to have two inequalities to represent the distances that are greater than 4 from 0. Remember what we said, an or statement normally points opposite each other. And let's look at this another example. What does absolute value of x less than 4 really mean? We have less than, so that's an and. All we got is all the numbers whose distance from 0 is less than 4. So step 1 said rewrite it as a and or an or statement. So let's take the first one, drop the bars, rewrite the problem. Second one, drop the bars, multiply by negative 1. Remember, when we multiply by negative 1, we flip the sign. X greater than negative 4. So we have x greater than negative 4 and x less than 4. Remember, we said and statement normally point towards each other. So I have an open circle with negative 4, closed circle, open circle with positive 4. Less than 4 is pointing left, greater than negative 4 pointing right, so they connect. Notice that you need to add two inequalities to represent the distances that are less than 4 from 0. Right? Let's look at another example. Right? Step 1 said to do what? Right? We need to separate this into an and or an or statement. So I'm going to rewrite, drop the bars. Second one is drop the bars, multiply the right-hand side by negative 1, flip the sign. Now we need to solve. 3, x less than or equal to negative 4. We had 3 torrs, so I should have written an or at the beginning, and then should write or at the end. Now I'm finished solving. I need to graph next. So let's draw a number line. I have an open circle at positive 3, pointing to the right. Open circle at negative 4, pointing left. Notice that these ors are pointing opposite directions of each other, and that's the normal or statement. Now let's write the solution in interval notation. Let's look at the left part of the graph. Smallest number is negative infinity to negative 4. Since I have an open circle, I got parentheses. Right hand side, smallest number is 3, largest number is infinity, parentheses, because I have open circle, and we have the U or union, which means or in the middle. Let's look at the next example. We have less than, so we have an and statement. We're going to rewrite, drop the bars. And drop the bars, multiply by negative 1, flip the sign. Next we need to solve. We have x less than 8 and x greater than 2. Let's graph this. Normal ands do what? They go towards each other. Let's see if this one goes towards each other. We have an open circle at 8 on left, open circle at 2 pointing right. So they do point towards each other. We could write this as a compound inequality. With smallest number on the left, largest number on the right, with our variable in the middle. Now let's write this as in interval notation. Smallest number is 2, largest number is 8. We have parentheses on both sides because we have a circle. Let's look at this next example. This one looks a little bit differently because now we have to do step 1, which is isolate the absolute value. This means what's outside the absolute value on the same side as the absolute value. Here we have 2 and the subtract 3. So the first thing we need to do is get rid of subtract 3. Now we're going to get rid of the subtract 3. Add 3. So we have 2 times the absolute value of x minus 4. Alright, now we need to get rid of the 2. This is 2 times the absolute value, so we're going to divide. We got absolute value of x minus 4 greater than 4. Now we've finished isolating, so now we have to do step 2, which is set up 2 inequalities. First one's easy. All we do is drop bars and rewrite the equation, or the inequality here. The second one, we drop the bars, multiply the right-hand side by -1, which means we have to flip the sign. Now we're going to solve. X greater than 8. We have x less than 0. And since this was greater, I should have written the north there. We now solve, so we've done step 3. Now we need to graph. Normal ors point away from each other. Is this a normal one? Well, let's see. We have open circle at 8 pointing right. Open circle at 0 pointing left. Yes, they do point in opposite directions. So we have a normal OR. Now let's write this in interval notation. With negative infinity to 0, union, or 8 to infinity. Now let's look at this example. I've worked it out for you. We have great or equal to. So we have an or statement. Notice I've solved it. But let's look at our graph. What are the graphs doing? Ors normally point opposite of each other. These ors, the graphs are pointing towards each other. When we have this, the solution is all real numbers. So our graph should have just looked like a straight line. How do we write it in interval notation? Well, negative infinity is my smallest number. Positive infinity is my biggest number. Let's look at one more example. We have the absolute value of 2x less than, so we have an and statement, negative 4. Now, I rewrote it. Notice, let's look at our graph. Ands normally point towards each other. Look at this graph. The ands are pointing away from each other. And for this statement to be true, both have to happen. Can any number make both statements true? No. Therefore, we have no solution. How would we write that? Interval notation. We have our interval with blank. Now I would like for you to try these 4 problems on your own. Make sure you're following the steps, make sure you're graphing, and make sure you write your solution in interval notation.